Okay, so the first thing I might do on part A is to go ahead and draw the normal curve. It says we have a mean of 8, so in the middle is 8, and a standard deviation of 2, so you add 2 in each direction, 10, 12, 14, 3 standard deviations above, and 4 and 2, 3 standard deviations below. Then it says to find from 7 to 9. So from 7 to 9, we're trying to find that area from 7 to 9. So you might shade um, in that area, like from here to here, which is, even though that's not that much distance, less than about a half a standard deviation each direction. It's in the height of this normal curve, so it's going to have quite a big percentage. Maybe not 50%, but maybe close to 50%. Let's kind of do some conversions with this 7 and 9. So remember the z-score. So z is x, which would be 7, minus the mean, which is 8, over the standard deviation, which is 2. So our lower z would be negative 1 over 2. And then take 9. So your upper z would be z equals 9 minus the mean of 8 over the standard deviation of 2, which is positive 1/2. So you might say it this way: the probability of z being in between negative 1/2 and 1/2 is equal to, then get your calculator out and type in this information, and you get 0.38. So 0.38. Now, if you read the directions closely, it says determine that probability and express this as a number between 0 and 1. Round this to the nearest tenth. If you didn't read that, they might still mark it correct, but they want you to round this to 0.4. So that would be our answer for this one. Now, just so you see the answers that was provided and the way they grade it, they accepted it if you said norm CDF 7982. If you didn't even convert it, that was an acceptable approach. They prefer this, and this is what I prefer you to do, something like that, where you link the z-values to your probability there. Let's look at part B. So if you do part B, push that down for a minute. You basically use whatever number you got in part A. So in part A, our answer was 0.4. If you remember, we rounded it. If it was 0.38, you could use a 2-digit simulation here. That would be okay. But I think it's going to be easier for us to do 0.4, so I'm just going to pick 4 numbers. So we might assign numbers 0 through 3, might be assigned to, what is this? To determine the number to find 2 pearls. So this is for finding 2 pearls. So this is success, which is finding 2 pearls. And then the digits 4 through 9 are failure to find the correct amount of pearls. Basically, you'd want to say something like that. And so describe how you would do it. So you need to describe something like you would use, a random number table. You want to say this in sentences. Random number table. You're going to, each time you get to a digit 0 through 3, it's going to be a success, and you keep going until you find, by the way, this was, I think I misspoke here, this was finding 1 pearl. So the random number, you keep going until you find 2 successes, in other words, 2 pearls. So you have to, it's that waiting time, that's what they call the waiting time of this. So describe in a sentence, keep going in the digits, ignoring digits 4 through 9, keep going until you find two different digits from 0 to 3, and then that's the end of your trial at that point, and you would be done with that trial. So here's the definition they gave. There's an interesting part of this where I wanted to just see the value used. If you got A wrong, like if you got 0.7 there or something, and you did B based off 0.7, B is still correct. So it's okay if you got this one wrong, you could still get part B right based on wrong information. They allow that. So that's an interesting point. So then the third step is you actually have to perform the simulation. And so you would go through and you would make some markings on here. Perform it 3 times. So start at the upper left digit. So you might say, okay, trial 1. And so you cross that out, ignore, 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 ignore. Wow, we're not having much success here. And we have a success and a success. 0 through 3 are, one pearl, one pearl. So we end our trial there. At the end of trial 1, and that was 1, 2, 3, 4, 5, 6, 7, 10. 10 out of 12. So it took 12 tries. And trial 2, it probably would have been good to specify in our directions that we were going to go to the next number line to start our next trial, or whatever your plan was going forward. So end of trial 2. It took 5 tries. And the rubric for this one, I'll let you one more trial, sorry. And the third trial was 1. And so that took 7 tries. So you do 3 trials, correctly run 3 trials. More is okay, and acceptable approach. Okay, so those 3 really not too bad. Okay, sorry about that. Ignore that for a second. So what this is asking, and it's kind of a difficult question, is which one is between 4 and 6.5? Well, the question is, identifies A or B, represents the search for 7 to 9. So which one, which distribution here is simulations, simulating finding 7 through 9. So we know that between 7 through 9 is a 40% chance, or 0.4. If we did from 4 to 6.5, this area in here, we could figure out it's definitely smaller than 40% just by looking at it. You could use your norm CDF to use z-scores and figure out the percentage. That's actually considered a bonus here if you did. But it's smaller. This is definitely smaller than 40%. I'm not sure what it is, but it's smaller than 40%. It's going to be more difficult to choose this than this. So if you look at these, which one was it more difficult? It'll match this one. So you can see it took a lot more trials. If you look at the x-axis is the number of oysters opened. The maximum number of oysters here was 14. The maximum here was 29. So it took a lot more tries to, the scale is different here. If you look at the x-axis scale, it took a lot more tries here. So I think this distribution seems to go with this one. And it took a lot less tries, so it's a lot easier to get a 40% chance of getting it in here. And if you look at our simulations that we did, if you look back to ours, it was like 12, 5, and 7. 12, 5, and 7, fit 12, 5, and 7 fit a little easier in this one than 12, 5, and 7 over here. It just goes a lot higher over here. So you would have to say for those kinds of reasons. So the reasons they gave in their official answer here Um, Again, you got bonus points if you, well, it helped certainly to figure out the probability of that was like 20%, so it's about twice as hard. Um, there's the official definition, but that's basically how you choose that. And that was I thought a difficult question. Let's get this out of the way here. Let's look at question the next section. So using the result of D, whatever we chose as D, by the way, if we chose the wrong one, we could still get the right answer here by using whatever we chose in D. We chose the first one to compute an estimate of the expected number of oysters to find two pearls between 7 and 9. So I want to find, you've got to identify what you're finding here, and you want to say it in words. We're finding the mean of distribution A. So if you go back to here and finding the mean, and you might want to say something like the mean, which is the balance point. If you're looking at a distribution, one way of finding the mean would be to find out where it would balance. So if you were to, it's skewed right here, so it's going to be not quite in the middle, maybe a little bit to the right of this. I'm not sure. Maybe around 6. It looks to me like that might be the balance point. So the mean might be somewhere around 6. I'm just guessing there. So I might say something like a mean of 6 to find the expected number, or maybe I should say the expected number would be 6 here. Now they did it a little bit more accurately than that. Using a formula, it was like 5.26. But I think if we just estimated and found something around 5 or 6, I think we'd be okay. As long as we said, we were trying to find the balance point or something like that. And that is the end.